Today we're talking about two-way tables. So this is one of the data displays that we talk about to show information when we have two sets of data that we're talking about. A two-way table is showing two different categories that are coming from the same source. So here's the example that we're looking at for our first description. You randomly survey students in your school about their grades on the last test and whether they studied for the test. The two-way table is showing the results. Each entry in the table is what we call a joint frequency. So the joint frequencies would be all these numbers as separate individual numbers. So what you'll notice on the two-way table is we have too much information to make one table that's either going up and down or horizontally left and right. So we've kind of merged them together. So here's the information about the students and how many of them studied or didn't study coming down in these columns. Here is the grades, whether they passed or failed, going this direction horizontally. So it's kind of like merging same information, but with different parts. So the same number of students and their grades, but they're kind of put into two ways of showing it. So let's try to read through one of these and see what it looks like. So example 1. How many students in the survey studied for the test and passed? So what I would just do is I would say, well, here's the studied column, and then here's the passed row. They meet right here. So first answer is going to be 21 students. And you always want to include labels when we're talking about word problems. So we had 21 students who studied and passed. Now we did have one that didn't pass and they failed, but this question was looking for the two things. Okay. Secondly, so marginal frequencies. So a marginal frequency is a little bit different than the joint frequencies. So the marginal frequencies actually adds another row and column to our table. So the sum of the rows and columns, this is called your marginal frequency. So here's how this works. So if I'm looking for my marginal frequencies, I'm just going to add it to this table here. So we're basically now adding a new piece. Okay. Basically, this is like a total column. All right. So we would look at our totals. So to find the marginals, we would be adding or doing the sum of all of our rows and all of our columns. So 21 and 22 is 23. 1 and 6 is 7. Adding my columns down would give me a 22 and an 8. Now I want you to notice this box in the lower right-hand corner right here. This is an important box because when I add my marginals down and I add my marginals across the bottom, they should be giving me the same answer. 23 and 7 is 30, 22 and 8 is also 30. Now let's just talk about what this is all telling me. So the marginal frequencies are basically telling me if I look at a topic. So let's look at my students who studied. If I add it down, I have a 21 and a 20, I'm sorry, 21 and a 1. There are 22 students out of the group that we talked to that studied. There are 8 of our group that didn't study. There were 23 that passed, and there were 7 that didn't pass. Okay? And the big important thing is, well, how many students did we survey? Well, right here is the number of students that we talked to. So that marginal frequency in that lower corner helps us verify that we have the right answer, but it also then tells us how many people maybe we're talking about in our study. Okay? So to go through this, it says down here to find and interpret the marginal frequencies. So the marginal frequencies, let's go through it this way. So we have 23 across our top row. Remember, interpret means tell us what the numbers mean. We have 23 students passed. The second row tells us we have 7 students. I hate writing failed, but didn't pass. Okay? Then, doing our columns down, we had 22 students studied, not studies, studied, and 8 students didn't study. And maybe the last one that you want to include too is we have 30 students surveyed. So when we're asked to interpret, remember that means we are talking about doing how our numbers and what they mean. So when it says create a new column and new rows, we kind of already did that. And that's how you would add on a new row and a new column to get your marginal frequencies to fill in the table above. Okay? So here's another example. So now we're going to make one of these things. So we have some information about students who are ages 12 to 17 about whether they ride the bus to school or not. So the little tally sheets here kind of show us. So there isn't a right or wrong way to do this. You could do across the top one of the columns and across the bottom the other one. The labels are really up to you. So here's how I'm going to do this. So I'm going to say rides bus. That one's going to be the one that I'm putting across the top. Now, what are the choices? Rides or doesn't ride? So I'm going to put no and yes. Okay? Actually, you know what? I'm going to change that. And don't have to change this, but I'm going to change it to this. Because the top one is that they do ride, I want to put that one first just so I don't make a mistake here. Okay? So then, here's what I'm going to do next. So, going down the side here, I'm going to go age. And I need to make sure I have all of these ages, 12 to 13, 14 to 15, and 16 to 17. So I have 3 rows and 2 columns, and there is a two-way table. Now you might decide to have the age on the upper one and the rides the bus on the side. Not wrong, just make sure we now plug the information in. Okay, so I'm just going to go through the rides of the bus column, which is this one first. So if I look at my rides of the bus, so the 12 to 13s, 5, 10, 15, 24. So 24 will go into the 12 to 13-year-olds. When I look at the 14 and 15-year-olds, I have 10, 12. And when I look at my 16 and 17-year-olds, I have 14. Those are all the ones that ride the bus. Then I look at the doesn't ride or no to the ride. My 12 to 13s, 5, 10, 15, I have a 16. I'll put that in a different color. And then when I look at my next row, 14s and 15s, I have 13. And when I look at my 16 and 17s, 5, 10, 15, 21, I have 21. Okay, so this would be my two-way table. Now they're asking me to include the marginal. So remember, the marginals is the totals. So this is where we kind of extend all the rows and the columns. And what we would say is maybe put over here total. And then what we do is we add across and down to get our new marginals. So the marginals are the ones that are giving us the sums. So if I go across my 12 and 13 row, 24 and 16 is 40. 12 and 13 is 25. 14 and 21, you gotta be careful I didn't get caught that that's in 27 somehow. That's 21 is 35. When I add down, 24 and 12 and 14 is going to be 50. And then 16 and 13 and 21 is 50. And here's where we kind of get two benefits from this lower right-hand corner one. They should both be giving me the same number to make sure I didn't make a mistake on my numbers. It also gives me some information about how many students we talked to. And they both would add up to 100. Okay, so this is not asking me to do interpreting these, but let's just do it. We'll do it verbally. So this table, including for my marginals, this is right here is telling me that 40 of the 12, we talked to 12 and 13-year-olds, 40 of them. We talked to 25, 14 and 15-year-olds, and 35, 16 and 17-year-olds. We also know that 50 of that group ride the bus and 50 don't ride the bus. We talked to a total of 100 students. Okay? Now, then we want to talk about this next example. Okay, so for each of the groups in example 3, what percent of the students ride the bus? What percent do not ride the bus? And then we want to determine whether there's a relationship between the age and riding the bus to school. Okay? So we can do this in another two-way table. So let's just keep the two-way table we have. Oop, keep the two-way table we've got. Oh my goodness. And what we're going to do is recreate the table. So we're going to say yes. We're going to say no. 12 to 13, 14 to 15, 16 to 17s. So basically what I'm doing right now is I'm recreating the table, but this time we're going to be using percentages, not our raw data. Okay, so percentages. Remember our percentages back from the past. What we're going to be talking about is the percent. So a couple of things we're going to remember. So we're doing it for each age group, and that's important to notice. We're not doing it for the overall group. We're doing it for the age group. So what I want to focus on, if you remember doing percents, you do the amount that you have over the total amount. So for example, for our 12 and 13-year-old group, how many students did we say we had? Well, we had a total of 40. So our total 12 and 13-year-olds was 40. 24 ride the bus, 16 don't. So we need to use that information to figure out our answer. So we have 24 that ride out of 40. We have 16 out of 40 that don't ride. So what we have to do is we've got to figure out what are those as percents. And remember, like I said, what you do is you just take your numerator, divide it by the denominator to get 0.6, and then you turn that into a percent, which means 60%. 16 out of 40 means 0.4, but then that as a percent is 40%. So the 12 and 13-year-olds, 60% of them ride the bus, 40% do not. When I move on to the next group, let me change my color here. My next group, the 14 and 15-year-olds, let me scroll back up. We have 12 out of 25 that take the bus. And then we have 13 out of 25 that don't take the bus. Okay, so again, if I do 12 divided by 25, I get 0.48. As a percent, that is 48%. 13 out of 25 is 0.52, which then gives me 52%. Okay, so just using our fractions to be able to find these answers. And then my last one is, we're talking about the older kids. So 14 out of 35 and 21 out of 35. And then we've got to go ahead and just figure out what those numbers are. So 14 out of 35 is 0.4, which is 40%. 21 out of 35 is 0.6, which is 60%. And now to know that I have this correct, think about what we just did. We're focused on the age group. So shouldn't this row be 100%? Because that means we're including all the 12 and 13-year-olds. Shouldn't this add up to 100%? And shouldn't this add up to 100%? These numbers will not add up to 100% all of a sudden and don't necessarily equal each other. But we're focusing on the age groups. So these should all add up to 100%, which they do. Okay? And then determine whether there's a relationship between their age and riding the bus. So looking at my information now, I want to kind of get a read for what is this all telling me? Well, the highest percent of kids riding the bus is the younger ones. The highest percent of the kids not riding the bus are the older ones. So that kind of says there's a relationship right there to me. So I might write it this way. The older the kids get, the less take the bus. Which kind of makes sense, especially once you get to that 16 to 17-year-olds. A lot of times that's when people start getting their licenses at 16 and a half. So it would make sense that maybe they're driving themselves, or they also might just have friends that are now driving that they can catch a ride with, and so that they don't have to take the bus. So that's the two-way tables. It's a way to help us organize information in two ways from the same information, and hopefully that makes some sense. If not, we'll be working on it in class, and certainly feel free to ask when I see you this week.